making sure I have my signature. So we know that secant is related to cosine. This is 1 over our cosine of x. So to graph our cosine and our parent function, that's when we're gonna do our same kind of counting as normal, where we usually had started our pi over 4 and our pi over 2 and our 3 pi over 4 and our pi. 1, 2, 3, 4, and our 2 pi. And that's because this is just our parent function. That is definitely not 2 pi, that is just 1 pi. 1, 2, 3, 4, that's our minus 2 pi. And we can count like that because this doesn't have any transformations on it, so our period length is still gonna be our 2 pi. Our left endpoint is 0, and our right endpoint is 2 pi, because that's how long it takes to go around our circle. It's our parent function, so our amplitude is just 1. So when we're looking at our cosine, where does cosine start again? Cosine starts at 1, and it ends at 1. And halfway through is at -1. I saw Miss Glaze is apparently teaching like this to help us remember with cosine, which cosine factor B, cosine's the crane kick. Cosine. We have high, and then a low point down here. So high with a low in the middle. Cosine. Okay? I learned that yesterday. So those of you who had Miss Glaze, imagine Miss Glaze doing that. She taught me that. Like. Okay, so it's high on either end and low in the middle for our regular basic cosine. Halfway between those is when we hit our zeros. So the first cycle of cosine looks like this. And then it continues outward. So that pattern continues down like this. It goes down and then back up, so we get crane kick number 2. So that's cosine. The process for secant is very, very much like cosecant from yesterday. So wherever we are hitting that center line, hitting that midline, in this case it's right on our x-axis, that's where we're going to have our asymptotes. So we're going to have asymptotes. Our first one's at that pi over 2. It's the first place we get a 0. And then we have one at our 3 pi over 2. We have one at 5 pi over 2. Our minus pi over 2. Our minus 3 pi over 2. And our minus 5 pi over 2. So our asymptotes are happening on an interval every pi, right? This was a plus pi. This was a plus pi. This guy's a length of pi. So every pi, this is happening. It's for our secant and cosecant, it's always going to be half of the period length because it hits that 0 in the middle. So our asymptotes happen every pi. And our first one was at the pi over 2. So our asymptotes happen when we have pi over 2, that first one, plus pi, any number of times, pi n.
Why is it pi over 2 plus pi?
So our first asymptote happened. The first place we had a 0 was pi over 2. And then this is happening every, it would be a half circle on the unit circle when we get our next 0. So the space between is going to be pi, and it should always be half your period length. So since the period is 2 pi, we know it's going to hit twice in there. It's going to be half that length. And it doesn't have to be pi over 2. You can pick whichever one to base it off of. If you want to do minus pi over 2 plus pi, that's fine. I just tend to pick the first one we get, positive. So then, just like we did with cosecant, we know that when we take this reciprocal, if I take the reciprocal of 1, it's just 1. And then since this gets smaller here, the reciprocal is going to get bigger. So it's going to go up, 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 and approach my asymptote. It's going to go up, 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 and approach my asymptote. This one's going to have my reciprocal of -1 is -1. It's going to approach my asymptote this way, and it's going to approach my asymptote that way. My 1, and approach my asymptote. My 1, and approach my asymptote. Oh, where did I lose you? I heard and I'm confused. Okay. It's like, if I know your question, I can answer it. If I don't know your question, I can't do nothing. So very much like yesterday, since we're taking the reciprocals, we know it's going to be bigger. If we think about this one being our 1/2 on cosine, because we have a cosine that equals 1/2 when we're looking at our, so think about our pi over 3. Like pi over 3, we know that, guys, right about here. We have a cosine of 1/2. When I take the reciprocal of that, we're at 2. So that's why it's going up here. We're taking our reciprocal. 1 over these fractions gets real big. But we know we cannot equal 0 because if I divide by 0, we get something undefined. So our domain, we're looking at just our purple pieces here. What is our domain for our secant? All real numbers except x cannot be this guy, my asymptotes. X can't be anything on those asymptotes. Pi over 2 plus pi n. It cannot hit an asymptote. It can't cross through it. How about our range?
-infinity to -1.
Mm-hmm.
Then 1 to infinity.
Yep. -infinity to -1 because we're just looking at the purple parts. And then we're going to join that. So union 1 to infinity. We jump over cosine entirely. It flips. Okay? Because the graph of secant, just like the graph of cosecant, is just that part. So you don't have to have the bit in the middle, but drawing it without the bit in the middle is really challenging. So I usually draw it like this. If you want to do that and draw it like that, more power to you, but that's really hard. I like it like that. That makes it way easier to deal with. Okay. Questions on this one? Okay. Let's do another one. I'm going to do a secant. You get secant of 1/2 x minus pi over 2, and then plus 1. Rah. What do we notice? Yeah, we're not on our x-axis here. We've got this plus 1. Our center line is going to shift up 1. So we're not based off our x-axis. We're based off of this. This is what I'm going to graph my cosine on with all of our transformations. So this is my midline. This is where we base everything. That's what we get from that. So what we need to do next is we need to graph our cosine with these transformations on that line. That is definitely the easy way to do this. So let's look at cosine of 1/2 x minus pi over 2 plus 1. So it's off that midline. So what is the period length here? It's the 2 pi divided by 1/2. Yep. Or 4 pi. I was like, I heard it. I was just letting other people hear it too. I heard it. You had it. Okay, so our period length is 4 pi. So we know we're definitely going to need to count by smaller amounts. Let's make sure we have enough space to get everything. So let's find out our endpoints. So we want to know when our 1/2 x, I'm just going to do it up here just because I'm out of space at the bottom, minus pi over 2 equals 0. That gives us when it starts at the left. So we're going to add our pi over 2. So we have our 1/2 x equals pi over 2. So where is our left endpoint? Pi. Multiply both sides by 2. So we're going to start at pi. Then we find our right endpoint the very same way, except we need to make it equal to 2 pi. Let me scooch this thing over just a smidge. There we go. So we're going to take our 1/2 x minus pi over 2, and I want to know when that equals 2 pi. So again, we're going to add our pi over 2. So 2 pi plus pi over 2, so 4 pi over 2 plus pi over 2. And have our 5 pi over 2. So our right endpoint is at 5 pi. You could also take our left endpoint and add our period length to get there, but our right endpoint is going to be at 5 pi. So we need to make sure when we're counting this that we can get all the way from pi to 5 pi and have 2 full periods on here. So I'm going to actually count by pi over 2's because I have enough spaces here to get there. So if you want to just count by pi's, that's totally fine. It's okay if we count by different things. But I'm going to do pi over 2 and pi. We're just going to make this guy 2 pi, bless you, and 3 pi, and 4 pi, and that gives me 5 pi right here at the end. Minus 2 pi. Again, if you count by 1 pi, that's totally fine. But if I can get from minus 5 pi to positive 5 pi, then we'll have 2 full period cycles there anyway. So we're good. So now we're going to do our cosine that's on here. We're going to start at pi, so our left end point's at pi. Where do I start with cosine?
1.
Yeah, up 1 from my middle line. My waist is my midline. So I have 1 point that's up high. I need to go up from my midline by our amplitude. We don't have anything up front, so our amplitude's 1. So I go up 1 from that center line on pi. So here should be my left end point.
Would it be like the opposite way for your sine?
Sine starts on the center line. Cosine starts above it. So sine is on the line, which works if everything didn't rhyme with line, but everything rhymes. So we know at pi we're up, and at our end point, matchy, crane kick. So they're gonna match. So at 5 pi, we're also up 1 above the midline, our amplitude above. So the halfway point right in between, we need to have our low point. So halfway between pi and 5 pi is right at 3. Halfway between 1 and 5. And then halfway between each of those is where we're going to have our zeros. So this gives us our first cycle of cosine. Should look kind of like that. Great. We will continue it. I was like, I would just do the first cycle, and I'm doing the next cycle in a slightly different color so we see. So we're continuing it on. I just would like to do my dots because it makes it easier to graph it. So we're going center down, center up, skip center down, and it's gonna look like that. This one we have to fight some of our instincts on our asymptotes here. Because where are we going to have asymptotes? 0 is going to have an asymptote. And 2 pi has an asymptote. That was a bad one, but you get the vibe. Bless you. And 4 pi has an asymptote. So we have to fight our instinct. It's not where it hits the x-axis. It's where it hits this center line when the cosine would be 0. I don't care how it's been shifted. It's when my cosine would be 0. So it's every place where it's hitting that center line. So in these cases, it's right on 0 and 2 pi and 4 pi and minus 2 pi and minus 4 pi. So our asymptotes are happening. It starts at 0, so 0 plus 2 pi plus 2 pi plus 2 pi. So we can write it as 2 pi n. Since it's right on 0, I don't have to put the 0 plus. You can if you want to. If it helps your brain, you can put the 0 plus 2 pi n. So we know we're starting here and then there's this shift. You don't have to though. 2 pi n is plenty of information. And again, it's going to be half of our period length here. So then we're going to do our secant, which means we're taking those high points, our highs and lows, and we're going to take that top point and approach our asymptotes on either side. Approach our asymptotes on either side. Approach our asymptotes on either side. Okay, so it looks a lot like these. Okay. Questions on this one? Yes, let's do domain and range on this one. I was just looking through my things because I was picking one to do next because the one I have in my notes next I don't actually like. And we don't need to because I just looked through all of our stuff. We don't need to take the challenge one that I have. So what is our domain for this secant function? All real numbers, except x cannot be equal to 2 pi times any integer. It cannot be 2 pi, it cannot be 0, it cannot be 4 pi, it cannot be 18 pi. What's our range here? 2 to infinity, because we're up 2. Yep, so just be careful on that one. So it's from negative infinity up to 0. And then we start again at 2 and we go up to infinity, okay? So they're awkward. They take some getting used to. Once we get the hang of them, they aren't like the super awful list, but they're not particularly pleasant. All right, let's do one more together. I'm leaving it up here for a second because I'm changing the one we're doing. Okay, so I want to grab one that has the minus sign. I've had a lot of questions about the minus signs one. So let's do, I'm not doing anything, I'm just writing it down. This one. Minus 1. I don't know that I actually have the answer key for it, so we're going to figure it out together. Love it. Adventures. Okay. Ready? I'm going to do this one. This one is actually number 5 on the homework. Okay. I'm picking this one because it's one of the ones that has the minus sign. And so I want us to be able to see that because we hadn't actually done one like that. So I want us to see the minus sign and what it does. Yeah, there was one on the first homework, but since we're practicing secant, let's practice secant again. All right. So, starting with our period, our left end point and our right end point. What is our period going to be on this one? So when we find our, we're finding the b that is usually inside parentheses here, right?
Also just 4x.
So 4x is the only thing that's in our secant. The -1 is outside. This guy's a k. Ooh, that was trash handwriting. What was that? Plus k. That's a k. If it doesn't have parentheses, we can only have this thing that's being multiplied a part of it. This is added on the end. Order of operations. These guys go together. The -1 is separate. So if it doesn't have parentheses, that's what's intended there. So this guy is a b. It's a part of it. We just don't have that other piece in there. So our period is going to be our 2 pi divided by that b. So we're dividing by 4. So our period length is going to be pi over 2. So it's short, very short. Where is our left endpoint going to be?
0.
Because we want to know when 4x equals 0, right? Well, that's just 0. To find our right endpoint, we want to know when 4x, that piece that we're taking our secant of, equals 2 pi. Pi over 2. So our right endpoint is pi over 2. So I don't want to count by pi over 2s, definitely. We might not even want to do pi over 4s, because we only need to go to pi over 2. I don't need a gabillion and a half copies of it. So we can count by whatever we want to. I'm going to go with pi over 8. Just so we can make this a little bit bigger and we can see. So here's my pi over 4. Here's 3 pi over 8. Here's pi over 2. And we're going to have our 5 pi over 8. 3 pi over 4. 7 pi over 8. And pi. So it's 8 units to a pi is what we're doing. Just go. Yeah, you can absolutely do that to do common denominator. Totally fine. So this would be 1, 2, 3, 4. This would be minus 4 pi over 8 if you want to do that. It means the same thing as pi over 2. 2, 3, 4 minus 8 pi over 8. Totally fine. As long as I can tell what you're counting by, I don't particularly care what's going on there. So we have a couple of weird things we need to watch out for on this one. Because we have our k of -1. So that means we need to move our midline before I start doing too many points. So it's down 1, so it's down here amidst all my denominators. There we go. So there's my midline. What do we have happening with the amplitude here? Our amplitude is -1. So we normally go up our amplitude for cosine and then down. So when we have our amplitude being -1, that's going to give us a reflection. So it's just going to flip it upside down. So instead of going up 1, we're going to go down 1. And then up, and then back down. So it does that vertical reflection just like it did in parabolas, just like it did in polynomials, just like it did in rationals, just like it did in exponentials. That vertical reflection over the x-axis. Same vibe. So instead of starting up 1 at our 0, we're going to start down 1 because we have that amplitude of -1. And then when we go to our pi over 2, that right endpoint, we are still down 1. And it's our halfway, our middle point, where it's up. So this one, even counting by pi over 8, this is still very short. Because we start at our -1, we're going to hit our 0, and 0. So we're going to go down, up, down, mid, up, mid, down, mid, up, like that. Go mid, up, mid, down, mid, up, mid, down, mid, up, like that. So that's our cosine. From here, we can figure out our asymptotes. Where are we going to have asymptotes on this one? Pi over 8, we have one, where we hit that midline. Every place we hit that midline is where we have our asymptotes. So we have bunches on this one because of the way I counted. So our asymptotes happen how far apart? One half of pi over 2 is right, but what is that a little bit more simplified? What is half of pi over 2? Pi over 4. Our asymptotes happen every pi over 4 units. Or if you're doing it where we counted by that same denominator, you could say it's going up 2 pi over 8 plus 2 pi over 8 plus 2 pi over 8 plus 2 pi over 8. That's the same thing as pi over 4. So when we're looking at where our asymptotes are happening, pick one of them that we're starting with. I usually pick our first positive one. You don't have to. You can pick whichever one you darn well please. But I tend to pick the first positive one. So our pi over 8 was our very first one. And then it is increasing every pi over 4. So we have pi over 4 times any integer we could think of. Pi over 4n could be pi over 4. It could be 2 times pi over 4. It could be 4 times pi over 4. It could be 500 times pi over 4. Every place we have a plus pi over 4, we will wind up with an asymptote. Oh, I didn't put it on here. Our -1 was our amplitude. I didn't put it on there. From there, we can grab our graph. I'm going to do it in, I already used the black one. I'll do it in like this dark blue. So our proper graph of our secant, we start at these endpoints and we approach our asymptotes. Start at these high points and approach our asymptotes. Each of the U-curves, I need to have at least 2 full cycles. I need at least 2 full periods. So I have a tendency to fill it in the whole time just because leaving it half done makes my brain itch. But as long as you have 2 complete periods, that is what we say in the instructions you have to have. So you would need 2 sets of up, down. So up, down, up, down. 4 of these almost parabolic pieces. They're not parabolas. They feel like parabolas, but they're not. So, oh, I missed an asymptote here. But that's okay. We have our 2 full periods. Okay. So what's our domain on this one? So it's are all real numbers, except x cannot be our pi over 8 plus our pi over 4n. Whatever we get for our asymptotes, however often they're happening, we have to include that repetition in there. What's our range on this one? To -2 and 0 bracket to infinity. Okay? Okay, so it does a vertical shift still, but it's not, like, I could feel like we were overthinking the vertical change, the vertical reflection. Okay. On Monday, we're going to talk about tangent and cotangent, and that would be the first 3 on that homework, the 6-6. Okay, so we'll talk tangent and cotangent on Monday because they're super duper related to each other. Okay. All right, so We have another quiz coming up. We'll have a quiz over all the graphic stuff.
I don't think is it just graphic drafting?
Quiz 3. I believe so, but let me know. I think it's mostly. If it's not all, it's mostly. Genuinely, I don't remember, and I don't have it over here. I don't have a copy of it over here, so I can't double check. Huh? I'll make one this weekend and I'll give it to you Monday. But I don't think I have one right now. Because it's very much based off of the two homeworks, the 6-5 and the 6-6. Boop.